first semester students, BSc.
Energy, it is either in form of any form of energy. So that energy only we say it is immortal. Energy can neither be created nor conserved nor destroyed. It transforms from one form to another form. That is immortality, I think, what we believe.
I deem it a privilege and an honor to be standing here to wish all of you all the best for this seminar on renewable energy organized by the Department of Physics, Don Bosco College, Tura. When the department approached me, usually I take time to ask, to allow all the science students to attend the program, because it's the program of the Department of Physics, but other students from the other departments like zoology, botany, mathematics and others, right, will miss classes. But then when I thought of the topic on renewable energy, I allowed the Department of Physics to invite all the staff of the science stream as well as the student to be here, because I think this is the need of the hour, to think, to discuss, and more importantly to learn in what way can we renew our energy. Dr. Barbara has already spoken to you about energy in a different form, right? Not the renewable energy that we see, right, presently, like for example, the energy from the sun, the renewable energy from the sun. She spoke about the energy that is there in each one of us. We need to have energy in order to do any of the activities. For example, our students, we need energy to study. And how do you do that? Like, to be able to concentrate in your studies, you need energy. By having proper food, proper sleep, proper rest, we will have that energy in order to continue doing well in our studies. The different ways when we talk about energy. But what we are focusing today, this morning, is on the renewable energy, and in what way can we make use of the renewable energy in order to look at the situation of what is happening today. Somebody came from down south just last week, and he was talking about, he said about, nowadays we talk about global warming. You have experienced that? These days it's becoming very hot. Last 2 days we had rain, and in spite of that the heat has increased. Usually in other time when there is rain, the weather temperature tend to cool down. But this time it was not so. After the rain there's a lot of heat because of the global warming. And he said we cannot call it a global warming anymore, right? Because the earth's surface is not warm anymore. He called it a global boiling. Global boiling. And we fear that next year, I'm not talking about a long term, what will happen after 10 years, 15 years, 20 years. We talk only about the next year. The temperature will rise by say 2 to 3 degrees. We have experienced that. What it was last year, what it is this year. We had less rain this year. That's why we had frequent power cuts. Next year it will be even worse. if we do not think about having renewable energy and how we can use the energy, it will be very difficult for us. So the topic of discussion that we're going to have today will really help us to understand what it means to use renewable energy. Some may accuse me and say, Father, you have got a big terrace, why don't you put solar panels, right, so that we can get and use solar energy in the college. I have been contemplating on that, I've been thinking of it, and there were other groups who have come to me, but the only problem is when we use solar energy, especially when we have solar panels, unless there is a proper maintenance, we cannot simply spend money to get those solar panels and at the end, after a few years, not working anymore. We did have solar panels where we use, but then now we are not using anymore because there was no proper maintenance. In order to use renewable energy from the sun, solar energy, etc., we need to have proper maintenance. And maybe the discussion can also be on what way we can also not only use renewable energy, but how to maintain when it comes to the usage of renewable energy. We pray that this seminar be really a learning experience for all of you dear students, and may it help you to transform not only yourself through the learning that you will gain through this program, but more importantly also transform the society in which we live. In this way, when we take a collective decision, when we take a collective action, we will be able to reduce at least a certain degree of temperature in the Earth's surface. May this be a real success, and may the deliberation and the presentation of the students be a grand success. Once again, I would like to thank the Department of Physics for the invitation given to me, and more importantly for organizing this seminar on renewable energy, and may it strengthen us to be able to really gain out of it and be able to use it for the gain of each one of us and human person. Wish you all the best, and God bless you all. Thank you. Mitchela.
And assistant professor of
dear students, very happy to see this hall full of science students. I know you all were eagerly clapping and cheering when science teachers' names were called out. Not so for me, but I don't mind because I haven't really met you in class, and earlier I used to teach science classes also. But it doesn't matter because we are all in the same college also, probably because I've been speaking every other day. So you know when somebody speaks a lot, then we begin to call the person a nag or something, and then we just lose interest. Okay. I'm very happy that Sir Mahendra started with that Sanskrit. No? So what he had said in physics, I will try to transform into art. I will try to chant. So, like, Asato Masa Gamaya Tamasoma Jyotir Gamaya Mrityorma Amritam Gamaya. Okay, so this is it. Thank you. Okay. So the same meaning, from ignorance to knowledge, from darkness to light, and then from death to life. If that is not renewal, then what is? We are always in the process of renewing ourselves. Of course, we'll be talking about renewable energy, but I think energy is, our being alive is being full of energy. Energy is life. Energy is the ability to move, the ability to think. And I think when we die, since we are also talking about energy as immortality, the energy is merely being transformed into something else. I know you all be talking about this energy in so many contexts, from physics, from chemistry, from botany, and from maybe some other perspectives also. And my knowledge is very limited, so I'll just stop with this particular concept here. But as I was thinking about this asatoma, sadgamaya, another thought came into my mind, that is about Indian aesthetics. Indian aesthetics has been very, very beautifully incorporated into Indian art. And I think we are familiar with that Satyam Shivam Sundaram. No? It comes in a song also in the movie. Satyam Shivam Sundaram. Okay, so truth, goodness and beauty. I have a feeling that when energy is expressed in honesty, in integrity, it becomes Satyam. And then when energy is articulated in art form, no, in aesthetic form, then it becomes aesthetics. And again, when energy is expressed in art form, it becomes Sundaram. Then when energy is expressed in conduct, good conduct, thoughtfulness, kind behavior towards others, understanding, empathy, sympathy, then it becomes Shivam. No? Because truth, goodness and beauty. Many a times we feel like this aesthetics, the science of aesthetics, or maybe more accurately, maybe the Indian aesthetics cannot be merged with science. But I think if we think it this way, when energy is converted into these forms, it can take very beautiful forms, and it can very well be synchronized, it can very well be gelled and reconciled with science. Okay? I would like to wish all of you the very best of Seminar 2023. I congratulate the teachers for having organized this, and remember that we are in it together because IQAC is there and we are all striving towards excellence. We are pursuing excellence, and this exercise of today, of you all going after epistemology, going after scientific knowledge, is only is a part of pursuing excellence, is a step towards excellence. With this, I would like to wish all of you a very good time, a time to gain knowledge and to apply it in your life. Father, very sorry, I've stolen your time. Thank you very much.
It is a privilege for me to speak in front of you today. The topic, as you can see, is the Aditya L1 mission by Indian Space Research Organization. It is called Aditya. I hope you know why it is called Aditya. What's the meaning of Aditya? Can anyone tell? Yeah, Aditya in Sanskrit it means the sun. As well as we have the Hindu god Aditya. So in honor of this name, we have called this mission as Aditya. And we have included L1. Do you know why it is called L1? Yes, you already know what is L1. There is a point where the gravitational force and the centripetal force between the earth and the sun, they balance each other, and they thought this is the best place where we can put the spacecraft for studying the sun. So let us see the main gist of the mission. Let us see. Aditya L1 Sun mission. It is the first space-based observatory class Indian solar mission to study the sun. This is not the first time that the scientists have studied the sun. Before us, we have also organizations like the NASA, we have organizations like the European Space Agency who have studied the sun. But this is the first time our own Indian Space Research Organization has sent a spacecraft, is sending a spacecraft, and it's on the way to study the sun. It is the first solar mission, and I think as we have already seen recently, India has achieved remarkable success, especially with the moon mission, which we call as the Chandrayaan, as well as now the Aditya is also on the way to L1, the Lagrange L1 point between the sun and the earth. This spacecraft is planned to be placed in a halo orbit around the Lagrangian point of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. Now, why they have chosen this L1? L1 is a very strategic point because in L1 we don't have things like the eclipse or interference by the Earth. So in L1 they will get an uninterrupted view of the sun. So there is a reason why we have chosen L1 for putting the Aditya spacecrafts to study the sun. What is Aditya L1? It is a satellite placed in the hollow orbit around the L1 point. It has a major advantage of continuously viewing the sun without any eclipse. If we are to study the sun from the Earth, we already know that eclipse may take place as well as interference of the atmosphere is there. The Earth's atmosphere itself will interfere. So to remove all this interference, we have decided to put Aditya on the L1, the Lagrangian L1 point. Now, this spacecraft, Aditya L1, has 7 important payloads carrying on the spacecraft. So these payloads are all indigenously designed by our own Indian scientists, by the scientists from IUCA, that is Inter-University Center for Astronomy and Astrophysics. We have Indian Institute of Astronomy in Pune, as well as ISRO. So these are indigenously devised payloads which will study the different aspects of the sun. So basically it will observe the photosphere, chromosphere and the outermost layers of the sun, the corona, using electromagnetic and particle detectors. So these payloads, the payloads which the spacecraft is carrying, will study the electromagnetic and the particles which are emitted by the sun. So now, with this mission, we will achieve some science objectives. Like for example, we will study the coronal heating and the solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature, anisotropy, as well as initiation of coronal mass ejection, flares, and near Earth space weather. If you study the sun, the parts of the sun can be divided into a number of areas. Like for example, the sun is having the core where the reaction takes place, especially the fusion reaction takes place in the core of the sun. And the temperature there is around 1.5 million million degrees Celsius in the core. Then after the core, we have zones like the radiative zone, convective zone, and after that we have the zone like I have already mentioned. We have the photosphere, chromosphere, and the corona. Now, this Aditya L1 mission will mainly study the events taking place in the photosphere, chromosphere, and the corona. Especially from the corona, there is something called coronal mass ejection which is taking place. At the moment, till now, we still haven't got enough knowledge about the sun. There are still many mysteries that is taking place in the sun. So there is the reason why we need to have such solar missions. Besides this Aditya L1 mission, Polar Orbiter mission by NASA, and there is another orbital mission by European Space Agency. These are also there. So this is one of the missions, we can say, and India has done remarkable in this aspect of the study of the sun. Now, uniqueness of Aditya L1, we have 4 points. This is the first time spatially resolved solar disk in the UV band. It is carrying payloads which can study the ultraviolet region. Then it will study CME dynamics close to the solar disk. CME is nothing but coronal mass ejection. Still, we do not know how this takes place. What is the physics behind the CME? So a lot needs to be done. So there is a reason why we need this mission. CME solar dynamics close to the solar disk, thereby providing information in the acceleration regime of CME, which is not observed consistently. Then we have onboard intelligence to detect CMEs and solar flares for optimized observation and data volume. And directional and energy anisotropy of solar wind using multi-direction observations. So these payloads which are being carried by Aditya L1 will study all this. They will measure the experiments in the instrument itself, in the instrument which is carried by the Aditya L1. They can also do the in situ experiments. They have spectrometers which can measure the wavelength, and you can get the inference out of these measurements. Why study the sun? Now, as we have already heard and we have already seen, I think the sun is the source of life, we can say. Without sun, we cannot have life. And as we have already known, it is an important source of renewable energy. The energy is continuously getting renewed in the sun because of the fusion reaction which is taking place in the core of the sun. So that is why we need to study the sun, and we get energy. The source of energy and the source of light is the sun. So without energy, I think we cannot have life. So that is why we need to study the sun. And let us see why the sun is the nearest star and therefore can be studied in much more detail as compared to other stars. So this is one of the reasons why we study the sun, because as we have already known, sun is also a star like any other in the galaxy. So by studying the sun, we can get important insights and we can learn about the physics about the sun. By studying the sun, we can learn much more about stars in the Milky Way as well as about stars in various other galaxies. And not only that, we have also other reasons why we need to study the sun. Because of the reaction that is taking place in the sun, energy is given out in the fusion reaction. The fusion reaction takes place. You already know what is a fusion reaction. When two protons they react, they fuse together and they produce helium. Not two, but four actually. But a series of reactions takes place. But in this process, light and heat is given out. Light and heat is given out in the reaction, in the fusion reaction. And in the process, again, protons are created. So the cycle goes on in the reaction. So that is why the process gets renewed. So therefore, it is a renewable source of energy for us. Now, another important thing that why we need to study the sun is the space weather. Now, space weather has a very important implications for us, for the life that is here on Earth, and especially with the coming of satellites that we put in the orbit, the interaction of the solar wind, the interaction of the particles which is given out by the sun. They have an impact on the satellite that is put, and as well as on future missions that we may have. We may explore the space in the future. So we need to know about the space weather. Now, talking about the space weather, it is not like the weather that we have on Earth. On Earth, we may have weather like the rain, the snow, etc. that we may have due to the weather conditions. But in the space, the weather is a little bit different. Now, in the reaction that is taking place, energetic particles and ions are given out of the sun, and they travel in all the directions, and it comes to us in the form of cosmic rays. So, study of cosmic rays or the ions which are coming out from these reactions is very important. And at the same time, we have what is known as the interaction of the magnetic field. Just like the Earth itself is having a magnetic field, the sun also is having a magnetic field around it. And this, we need to study this magnetic field, how it interacts. There is a reason why we need space weather, but unlike the weather on Earth, this space weather depends on the magnetic field, the magnetic interaction that is given out by the objects in the universe, in the sky. So that is the reason why we need to study the space weather. So by Aditya, we can also understand the space weather, especially with respect to the magnetic field and action of the cosmic rays which are coming to us and falling on Earth. Now let us look at the payloads that is carried by Aditya L1. So these are the various payloads, and it is we should be very proud of our country that all these payloads are indigenously developed by us, by Indian scientists. So that means we have achieved remarkably in this field. So first one, we have the visible emission line chronograph, VELC. We have solar ultraviolet imaging telescope. Then we have the Aditya solar wind particle experiment. This will plasma analyzer package of the Aditya. This will study the X-rays. Then solar low energy X-ray spectrometer, SOLEX. High energy L1 orbiting X-ray spectrometer, which is called Helios, and the magnetometer, which will study the magnetic field coming out due to the interactions in the sun. So these are the 7 payloads. Let us see a little bit in detail. These payloads, as you can see, has been designed by as you can see, the first payload VELC is designed by the Indian scientists at the Indian Institute for Astrophysics, Bengaluru. Then LEOS is Laboratory for Electro-Optic Systems. It is part of Indian Space Research Organization. So they have collaborated and they have prepared this payload VELC. We also have IISU, that is ISRO Inertial System Unit. Then we have SSE, Space Application Center, ISRO. So they have developed this payload VELC. SHOOT is developed by IUCA. It's an important institution, Inter-University Center for Astronomy and Astrophysics, which is located in Pune. So IUCA, LEOS, URSC and IISU have collaborated to develop SUIT. It will study actually as you can see, it will study the photosphere and the chromosphere. VELC will study the corona. It will take images of the corona. It will have some polarimetry and spectroscopy readings by the instrument. And it will also carry in situ experiments. That means these payloads are designed to take the measurements themselves. And these readings will be transmitted back to Earth. And the scientists sitting here on Earth will analyze this data. Then we have the SOLEX. It is purely designed by the center in ISRO, that is URSC. It's UR Satellite Center. Then we have the Helios or HEL-I1OS. It will study the hard X-ray. SOLEX will study the soft X-ray. Then we have the aspects, which will study the solar wind. This is developed by the Space Application Center, ISRO. For your information, we also have a Space Application Center in Barapani in Umiam. But I think this is designed by another Space Application Center, which is part of ISRO. Then we have PAPA, so it will study the solar wind. It will analyze the particles and the ions that is emitted by the sun. Then we have the MAG, which will measure the magnetic field that is given out by the sun. So this is about the payloads. Let us look in detail about the payloads that is there in the Aditya L1. So this is how the VELC payload looks like. It has a layer of insulation because this payload will be in direct contact with the sun. It is in the direction of the sun because it is put at L1. So this L1 is situated in the direct path between the earth and the sun. So there will be direct bombardment of the heat and energy that is coming from the sun. So there is proper insulation, and as well as it is designed actually to take the readings. It is having a spectrometer inside. Basically, it will measure the wavelengths that is falling on the spectrograph, and it will take the measurements. And once the measurements are done, it will relay back the measurement to Earth. So this is the duty of BELC payload. Then we have the suit, which is actually a ultraviolet telescope. It will study the ultraviolet radiation which is coming from the sun, and it will study. So it will take imaging. It is like a camera. This is like a camera which will take image of the ultraviolet radiation that is coming from the sun. It is also having a layer of insulation to protect it from the heat and the energy that is coming from the sun. So this is the SOLEX. So this is an X-ray spectrometer. So we will find that X-ray is also emitted by the sun. So there is a reason why we need to study the X-ray. Then we will this device or the payload will study the soft X-ray. Again, it is a spectrometer. It will take the readings and it will relay back the information to the Earth. And the scientists sitting on Earth, they will analyze the data, and after analysis, some important conclusions can be drawn. Then we have the Helios payload. So this payload will study the hard X-ray. And again, this is a spectrometer which is designed to study the solar flare in the high energy X-rays. Then we have the aspects payload. This is having two components. One is called the Swiss payload, that is solar wind ion spectrometer. We will study the ions. Then we have the STEPS, that is suprathermal and energetic particle spectrometer. So this will study the ions in the high energy portion of the radiation in the solar wind. Then we have the PAPA payload. This is designed to do some mass analysis, and it will carry out in situ experiments in the spacecraft itself. Then we have this magnetometer. This will measure the low intensity interplanetary magnetic field in space. It is having two sets of sensors. One at a distance of 3 meters from the spacecraft and another 6 meters from the spacecraft. So it looks like this, the spacecraft. We have the solar panels in the spacecraft which is powering the spacecraft, as well as it is having some propulsion system to keep the Aditya L1 in the orbit. It is having propulsion system, so if it deviates from the orbit, they will fire the propulsion system, and as a result of which the spacecraft can remain in orbit. So this is all about the payloads that is being carried by Aditya L1. So this is the picture of the spacecraft and the location of the different payloads on the spacecraft. You can see where it is located. We have all the payloads. Now let us look a little bit about the Lagrange point where we are going to put the spacecraft. Now, in between the Sun and the Earth, as you can see, we have 5 Lagrange points. And if you look carefully, we find that L1 is in between the Sun and the Earth, whereas the other Lagrange points are located elsewhere. So, L1 is a very good point where we can study the Sun. So there is a reason why they have decided to put the spacecraft at L1, which is L1 actually is around 1.5 million kilometers away from us. The Aditya L1 was launched by India after 2 weeks of launching the Chandrayaan moon mission on September 2nd. And I think it has now left the sphere of influence of the Earth. It is now cruising on the way to the Lagrange point at the moment. And it will take around 4 months to reach the Lagrange point. So it is expected that the spacecraft Aditya L1 will reach L1 somewhere around January. So it will be put in orbit at L1, and it will be put in the hollow orbit. Actually, it's like a circle. So it is not exactly a single point, but it will move in the hollow point, in the hollow area around the Lagrange. So this is another picture of the Lagrange point. Now why they have chosen this point is because the amount of energy required to keep the spacecraft at Aditya L1 is the minimum. If you see, if you put at L3, which is on the opposite side of the Sun, and L4 and L5, this will be very far away, and L1 is the nearest point, and to keep the spacecraft Aditya L1 at L1, it has the minimum energy. There is a reason why the scientists have chosen to put Aditya spacecraft at L1. Let us see how this payload was put into space. This Aditya L1 was put into space by our own indigenously built polar satellite launch vehicle. This PSLV rocket launcher is having 4 stages, and this Aditya L1 was released at the perigee, that is the lowest point surrounding the Earth, at around 200 kilometers. And the Aditya L1 is having a propulsion system. By careful maneuvering of this propulsion system, the Aditya L1 was brought into an elliptical orbit, and after around 4 stages, they have put Aditya L1 out of the orbit of the Earth. So now at the moment Aditya L1 is on the way to L1, that is the Lagrange point. It has already left the sphere of influence of the Earth. So Earth is having its own gravitational field. So up to a certain point, any object will feel the gravitational field of the Earth, and the end point is the sphere of influence. The last point is the sphere of influence. So once it crosses the sphere of influence, it will go out of the gravitational field of the Earth, and it will be on its own. And because of the propulsion system, it will cruise to L1. Cruise to L1, and it will be positioned in L1. And once it is reaching L1, actually all the payloads have started working already. They have already started to relay back the pictures taken on its way. And once it reaches L1, it will stay there for about 5 years, 5.2 years, 5 years and 2 months. So this Aditya L1 is having a lifespan of around 5 years. So after that, Aditya L1 will die down, and it will stop relaying the data and the information that it will get in the payloads. So this is the trajectory followed by Aditya L1. The PSLV rocket has put the Aditya L1 into the orbit, and by the propulsion system that is in Aditya L1, it has maneuvered 4 stages, and ultimately it has exited the SOI, or the sphere of influence of the gravitational field of the Earth, and now it is on the way to L1, and it will be positioned in the halo orbit at L1. So it is not exactly stationary, but it will be moving in a certain orbit which we call as the halo orbit around L1. And this movement of L1 around the Sun will be synchronized with the movement of the Earth, so that this spacecraft will always be facing the Sun. With the movement of the Sun around the Earth, with the movement of the Earth around the Sun, the spacecraft also will move along, and it will study the Sun. So these are the 10 major benefits of the solar mission. We will understand the solar dynamics. We have many mysteries which we have to study. Scientists still are yet to study fully and know fully what is happening in the solar system as well as in the universe. We will get in-depth solar particle analysis, we will probe the corona that is on the sun. Regarding this corona, I would like to tell that corona is the outermost portion of the sun, and it is very difficult to observe the corona with the naked eye. What we see with the naked eye is the photosphere. The photosphere can be seen with the naked eye, and the Earth-based readings can only take the readings of the corona. Only during eclipse, the corona comes into the picture. So now, by putting this Aditya L1 in L1, the Lagrange point, the corona can be studied without any interference from other planetary objects. So many things are taking place inside the sun. One thing is, as I have already mentioned here in the slide, we have the CMEs, coronal mass ejections. Coronal mass ejections are taking place. So we still do not know how these are taking place, what is happening inside the sun. We don't know exactly the dynamics that is going inside the sun. That is why it is necessary to study the sun. So many magnetic models can be unraveled. We can enhance space weather predictions. Then critical data for space assets. We have the satellites that we put on the Earth orbit, and as we all know, these satellites are very crucial for us in the modern world. We cannot live without these satellites. So to protect our assets, we need to understand the solar wind, the ions which are coming, how they interact with the Earth atmosphere. We need to know. That is the reason why we need to know more about the sun. Then, as we all know, this is a world-class observatory, and India could achieve this success in the first attempt itself. This is the first attempt, and so far we have been successful. If you look at Chandrayaan Moon mission, we have now the Chandrayaan 3, and Chandrayaan 1 and 2 have not been successful. So we have been successful only in the third attempt, but in the case of the solar mission, right away we have been successful. We could be successful in the first attempt itself. And ISRO, our Indian Space Research Organization, has done a very good job. So with this small presentation, I would like to once again thank the Department of Physics for inviting me. I hope we will also get more information as the students present their slides. Thank you once again. Thank you everyone. Thank you.